Let's roll in and take a look at that core component, that core object that we have, which is our tables. Let's start our discussion of tables with one of the core components of a table, and that's going to be a column. Columns describe the data that's going to be stored inside of a database. Now, the fancy term for this is metadata. It's just a great way to say data about data, and it's there to describe the information that's going to be stored. So consider, if you will, a table that is storing customer information. So we've got a table, call it customers, going to be storing customers. Then what you're going to notice is that we've got different columns there. So we've got customer ID, we've got last name, we've got first name, we've got join date, and we've got region. So those columns are going to describe the data that's going to be stored inside of there. Additionally, our columns are going to define the type of data that would be allowed to be stored inside of there. So for example, with our customer ID, that would be some form of an integer whole number data type. In case of our last name, first name, that's going to be string data type. Our join date would, of course, be some form of a date or maybe a date time. And then finally, our region would be, again, maybe some form of a string data, although it might point to another table, which is a little bit of an advanced concept that we'll be talking about in a couple of minutes here. So our columns define the data that we're going to be storing. They give it names, give it meaning, and specify the data types that we're allowed to use. The next component of a table is a row. And the row is actually our data. Now, sometimes people will call this records. The two terms are synonymous, that each row, each record, each entry, if you will, that's where we're describing, or we're going to have each item that's inside of that table. So if this is a customers table, then each row would represent one customer. So you'll notice that we've got the first one, which is going to have a last name of Harrison, a first name of Christopher, and a join date of 1/4/2012, and then the region of Northeast. And if we kind of roll through the rest of the items, each item there, again, is going to be a customer. It's my data. That is each individual entry that we're going to have inside of this table. So those are our rows. The last little thing that's worth highlighting about our table is a field. And a field is basically a cross point between a column and a row. And our fields are going to be individual values. So if we go through this first row, that first field would be customer ID, have a value of 42. That second field would be last name, have a value of Harrison. That third field would be first name, have a value of Christopher. Then we've got our join date. And then finally, last but not least, is we've got our region. And then our region is going to be Northeast. So each one of those individual values in SQL terms is known as a field. Now, when we create our tables, one of the things that we want to ensure is that the values that are placed inside of there are going to be valid. And this is where constraints come into play. That what a constraint will allow us to do is go beyond just simply a data type. That, for example, if I've got a data type of date time, then what I'm going to be saying is you're only allowed to place a date time inside of there. However, what happens if I've got maybe an additional rule? That you're not allowed to put a date inside of there that's before today. This is where a constraint comes into play. That a constraint is going to constrain the available values that are going to be placed inside of a particular column. Now, while constraints are nice, unfortunately, they are relatively limited in their functionality. That there's only so much that I can do with a constraint. So what happens if maybe I need something that's going to be a bit more advanced? Or I need to update one table or another in response to the user doing something to a different table. This is where a trigger comes into play. Now, a trigger is unique because a trigger is automatic. It's automatically going to execute code in response to some form of a modification. So you insert in a brand new value, and I'm maybe going to update another table for, say, auditing purposes. And so a trigger can do that for us. Almost all tables that you create inside of a database are going to have what are known as primary key. Primary keys are used to uniquely identify every single row inside of that table. The very common analogy for a primary key is a social security number, that a social security number is going to uniquely identify you. Well, a primary key is going to uniquely identify one particular row inside of a table. Now, if you do set up a primary key on a table, each row is going to be required to have a unique primary key. Now, I do want to mention primary keys are optional. You can actually create a table without a primary key. Generally speaking, you won't, but it is possible. They are designed to uniquely identify each row that's inside of there. On the flip side, we have what are known as foreign keys. Now, we're going to be talking a bit more about foreign keys in a few minutes, but a foreign key is used to create relationships between tables. Now, this is very important when we're going to be designing our database. Now, one of the big things about designing a database is we want to avoid data duplication. So, for example, I may have, say, a customers table and an orders table. So my customers can have orders. Well, when we enter in an order, we don't want to duplicate all that customer data, but we do want to make sure that we flag the appropriate customer. This is where a foreign key comes into play. A foreign key is a special type of column, and it's a column that's going to point at a primary key inside of another table. So I would create one column inside my orders table, set that up as a foreign key, and have that point to the primary key column inside of the customers table. Now, all of this leads us pretty perfectly into table relationships. Now, one of the things that we hinted at with a foreign key is the ability to create some form of a pointer, some form of, well, a relationship between tables. So the question then becomes, well, why would we ever want to do that? Well, the reason that we want to do this is for a couple of different reasons. First of all, to help improve the performance of updates. So for example, if I maybe need to change a customer's name, if it's only stored once inside the database, I only have to go to one spot to update that. But if that data is duplicated in maybe multiple tables, I then have to run around to all those different tables and update that, and that's going to slow us down. Additionally, if we divide up our data, this can potentially give us a little bit more flexibility in querying and reporting. So if I maybe want to put together one table that's got stores, I've got another table with customers, one of the things that I may want to do is join customers to stores that are close to one another. So maybe I've got city state or I've got zip code for my stores and for my customers. So even though I didn't necessarily create a relationship right up front between those two tables, if I've got some similar data between those two tables, I could then join that together and start to identify maybe some additional relationships between how my customers are buying products and get report data on that, maybe the proximity of a store to a customer on an average order, that I could go in and start doing things like that, even if I hadn't necessarily designed my database with that in mind. The last big reason to split data up into multiple tables is for data integrity. And this could include making sure that if we update a customer's name, that we only have to do it once and that I don't accidentally forget another table. Or it could be useful for scenarios where maybe a value might change, but I need to know what the original value was. For example, if I'm creating a database that's going to be storing orders, I don't necessarily care about where a customer is currently located. I care about where that customer was when they placed the order. So if I have a customer that's moved from San Diego to Chicago, when I start doing my reporting or I start looking to, maybe start giving bonuses to my salespeople, they want to make sure that they're getting the appropriate bonuses. So if I have a big customer that moved from San Diego to Chicago, I want to make sure that my salesperson in San Diego is getting credit for those San Diego sales and that my Chicago salesperson isn't now suddenly getting some bigger bonus just because we have a funky database update that now put a customer into Chicago there. So by splitting that data up, we're going to make sure that our data will stay intact. Now, the downside to splitting up data is the fact that quite frequently, in order to get the data that we actually want in the format and the structure that we want to be able to see it in, we will have to put multiple tables together. And what you're going to see is that we've got a lesson specifically dedicated to bringing that data together. This is really one of the core concepts to using a relational database, is bringing data back together to actually make it make sense. There are three main types of relationships inside of SQL: one-to-many, one-to-one, and many-to-many. Let's start off by talking about one-to-one. One-to-one relationship refers to a scenario where one row in one table refers to another row in another table. Now, this is useful for situations where we need to divide up data because maybe the other data is just not overly important, not accessed that frequently. So for example, we may have a scenario where I've got employees and I frequently need kind of basic employee information: their first name, their last name, their email address, their hire date, the office that they're currently in, things like that. But on the flip side, there might be additional information that I'm just not interested in, maybe on a day-to-day basis. So maybe certain applications are, but for the most part, we're generally not. And so this might be something for security purposes. Maybe we've got social security number, so we want to be able to lock that down. So maybe we put that into another table, so that way we can properly lock that down. This might be something like, the person that actually hired them. That maybe that is something that periodically we need, but we don't need that all that frequently. So we could put that off into another table. Now, one-to-one relationships are not very common. I don't want to say that they're unheard of, because they're not, but it's not something you're going to find yourself reaching for all that frequently when you're designing a database. The next type of relationship that we have is a one-to-many relationship. And a one-to-many relationship is where one row is going to refer to many rows inside of another table. Now, this could be for a parent-child relationship. Maybe we've got a situation where I've got one category, and that category could have multiple products. So that one category is going to refer to multiple products. Or maybe we've got a situation where we've got one customer, and that one customer has many orders. One-to-many relationships are going to be among the most common types of relationships that you're going to be creating inside of a database. The last type of relationship that we have is a many-to-many relationship. And this is where many rows refer to many rows. The most common example for this is products and orders, because one product could be ordered many times. In fact, I'm hoping that it'll be ordered many times. And then on the flip side, one order can have many products. Or again, at least I hope that people are going to be loading up their orders with a whole bunch of products. So what we need to be able to do is we need to be able to create that relationship. That's going to be a many-to-many relationship. SQL Server does not directly support creating many-to-many relationships. What we need to do is actually create two separate one-to-many relationships, where I'm going to have a table in the middle that'll be used to associate products with their orders or orders with their products. Sometimes that middle table that's going to be created is referred to as a join table.